Hello, I am Dr. Shigar Kanti, Associate Professor of Mathematics, Government First Grade College, KR from Bangalore. In this video, I am going to discuss the concept of uh, isomorphism in graph theory. Okay, two graphs. Definition is two graphs. Say G and H are said to be isomorphic. Isomorphic. Isomorphic if there exist a function f from vertex set of G to vertex set of H such that UV is an edge in G if and only if f of u, f of v is an edge in H. Okay, and clearly the number of vertices in G must be equal to number of vertices in H, and the number of edges in G must be equal to number of edges in H. Okay, and the adjacency is preserved here. That is, if two vertices are adjacent in G, then corresponding vertices in H must be adjacent. For example, I take an example. Show that G, I take a graph and H another graph are isomorphic. So here for G, to show that G and H are isomorphic, I label the vertices of G as U1, U2, U3, U4. So this is U1, U2, U3, U4. And correspondingly, I will label the vertices of H. I take this as V1, this as V2, this as V3, and this as V4. So that is here, this is V1, V2, V3, V4. And here, see here, U1, U2 is an edge, V1, V2 is an edge, U2, U3 is an edge, V2, V3 is an edge, U3, U4 is an edge, V3, V4 is an edge. And I can draw this graph. This graph as like this. That is just writing V4 here and V1 here. We can write this graph as H can be written as like this. This is our V4, V4 to V3, V3 to V2, V2 to V1. Okay. So that is there is a function from a vertex set of G to vertex set of H. That is here f of U1 is equal to V4, f of U2 is equal to V3, and f of U3 is equal to V2, f of U4 is equal to V1. So here U1, U2 is an edge. Okay. V1, V2 is an edge. U2, U3 is an edge. V2, V3 is an edge. U3, U4 is an edge, V3, V4 is an edge. That is your isomorphic, means they are nothing but the same graphs. Okay, so this is about the isomorphism. Let's take another example. Show that G, write G cycle of length phi and H. This is 1, 2, 3, 4, 5. I will join the vertices like this. Okay. Are isomorphic. See See here again, I label the vertices of G as say U1, U2, U3, U4, U5. Okay, and now I will label the vertices of H as V1, V2, V3, V4, V5. I will take this vertex as a V1. Okay, this V1. Then adjacent to this, I will take this as a V2. This vertex as V2. Then adjacent to this vertex as V3, V3. Adjacent to this vertex, that is this vertex as V4, and finally I will write V5. Okay. Now, if I write this graph H in a different way, first I will write what else is here 1, 2, 3, 4, 5. I will take this as V1, I will take this as V2, I will take this as V3, I will take this as V4, and I will take this as V5. See here, V1, V2, V3, V4, V5, V1. So that's V1, V2, V3, V4, V5, V1. These two graphs are same here. So that is here. This is G and this is H. This graph can be written, drawn like this. Okay. So therefore here G is isomorphic to, in this case G is isomorphic to H. Okay. Next I will consider another example. Here we can define the function here. U1 to V1, U2 to V2, U3 to V3, U4 to V4 and U5 to V5. Okay. Next I will consider one more example. Verify G and H are isomorphic. So here this is our G, this is our H. We have to verify whether they are isomorphic or not. See here, this graph consisting of 1, 2, 3, 4 vertices, and this graph consisting of 5 vertices. Therefore, directly we can write G is not isomorphic to H. G is not isomorphic to H. And we consider one more example. G this is our G and H 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, 5, 1, 2, 3, 4, 5. See, these are the two graphs here. See, 1, 2, 3, 4, 5 vertices. Here also we have 1, 2, 3, 4, 5 vertices. And we can draw one more edge here. Okay. Now, how many edges are here in this G? 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Number of vertices 1, 2, 3, 4, 5 are same. But number of edges, here we have 3 plus 3, 6 edges are here. And here we have 1, 2, 3, 4, 5, 6 and 7 edges are here. Therefore, here also we can say that G is not isomorphic to H. We consider one more example. Similar example I will consider G. I will take G same and H 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah. In G consisting of 1, 2, 3, 4, 5 vertices. H also consisting of 1, 2, 3, 4, 5 vertices, right? And number of edges in G 1, 2, 3, 4, 5, 6. Okay. Here number of edges are 1, 2, 3, 4, 5, 6. Number of vertices are same. And the number of edges are also same. Okay. But this G is not isomorphic to H. If I label the graphs and G and H, so it is not possible to find a function from vertex set of G to vertex set of H such that UV is adjacent in G if and only if f of U, f of V is adjacent in H. Because here, just we can observe that there is a cycle of length 4. Okay, there is a cycle of length 4 in H, but there is no cycle of length 4 in H. Or we can say that there is a vertex consisting of degree 4, but here there is no vertex consisting of degree 4. So this is one reason. With this reason we can say that G is not isomorphic to H. So that is here. G has a vertex of degree 4, but H has no vertex of degree 4. Okay, so therefore we can write G is not isomorphic to H. We consider one more example. I take G as 1, 2, 3, 4, 5, 6 vertices, and I will take I will join these two, and I will take one more graph H here. 1, 2, 3, 4, 5, 6. Join these vertices. Yeah. See, these are two graphs here. G consisting of 1, 2, 3, 4, 5, 6. H consisting of 1, 2, 3, 4, 5, 6. Okay. Number of vertices are same. And here degree of each vertex in G is 3, 3, 3, 3, 3, 3. Degree of each vertex in H is also 3, 3, 3, 3, 3, 3. Okay. Number of vertices are same, number of edges are same, and the degree of each vertex is also same. That is, this is a regular graph, three regular graph. This is also three regular graph. Even then, these two graphs are not isomorphic because we can give one reason here. So I will take this vertex as A, B, C. Okay. Now here in H we have a triangle. A, B, C is a triangle. That is, there are three vertices which are mutually perpendicular to each other. But we cannot find a triangle here. If we take start with any vertex here, there is no triangle consisting of any vertex here. So there is no triangle consisting of this vertex, no triangle consisting of this vertex, no triangle consisting of this vertex. So no triangle consisting of a vertex here. So therefore we say that G is not isomorphic to H. So that is here we can use the reason H consists of a triangle, but G has no triangle. That means here these two are different graphs. Therefore we can say that G is not isomorphic to H. Okay. Okay, thank you. I'll stop here.